Whoa.
我们去山里吗?
This is amazing.
This is a special room.
How cool is that? I've never seen that before. Whoa. This is amazing.
We are in the control room, the control center for this circuit board assembly company. And you have the heartbeat of everything. You can see all of the data, all of the metrics. You can see the industry that they've manufactured for. You have other down here, you have automotive, you have medical. Over here, you have multiple different items that are happening in real time. So this data is from today, and it's also accumulative for the whole entire company, plus it's for the month. You can see the different active regions in China that they are manufacturing for. So you can identify the different PCB, SMT, CNC technologies, the circuit board assembly technologies that they offer at this company. You can see it live and in real time as it reports. And it's popping up. You can see the multi-layer circuit boards, the single-layer circuit boards. Over here, you can see where their customers are located. And I noticed that the top 4 are English speaking. So I recognize the United States, you have Great Britain, Canada, Australia down below. That's pretty cool. And that's all real time. That is so amazing. So you pan over here, you have more data. These guys have so much data. They've spent a lot of time on their processes, not even talking about manufacturing, but their sales and marketing has been tremendous. You probably already know that if you're on the internet watching this video. You've probably already seen advertisements for this company. Here you can see for the year of 2025, you can see their normal orders, and then just above that are the rush circuit board orders. These are typically 100 pieces and below, and here this is typically 10 pieces or less. Those are all prototype circuit board orders. Overall, this is the building that we're in. So we walked through the gates here, and we are over here in this room now, but this whole entire facility belongs to this company. In total, they told me that they have over 1 million different clients at one time or another that have come to their company to give them money, either in person or most likely digitally online. These are the different machines and processes that they follow. And you'll see that this will change a little bit, but they identify how many people are working in those machines. So they have 12 people here that have currently done 397 units, but their target for today is 831. So you can see their targets, you can see what they've actually done, and you can see the number of people working in each of those steps that's required to bring the products to life for the customer. This is an overall dashboard. So this is planning. This is the future work that they have coming in. And then this over here is the daily work. This is actually what's happening right now, real live time. Okay, over here, you can see the same information that's over there, but you see 9 people are working on the machines, and you can see the different areas, like there's a little downtime on this one process. There's 15 people working here. These are the machines, and there's downtime, there's uptime. You can see how they're doing in their metrics and their KPIs for this company. All right, so we have the overall process for bringing a circuit board to life. You have the QC, you have the DIP, you have different steps here. And again, you can see the RIN. So they have 34 people here, the same items that you're seeing. It's all live time. Right here, 96% have passed, whereas down here, 100% have passed. So there's room for improvement. And if you know ISO, it's constant improvement. You're constantly trying to improve your process so you can be faster, more efficient for you and your clients. Here you can visualize, they have real-time live data for each of the machines that they use. So you have a stencil machine, you have multiple pick and place machines. We'll see that live. You can see that they have big machines, little machines for picking up the different components, the inspection station before it goes through the oven, and then finally from the oven all the way down to the collection of the circuit boards. So you'll notice this dashboard here is for the environmental, and it's really important these days. They're measuring the consumption of the electricity on the machines. They're measuring the temperature of the machines, and they're really trying to manage the machines so they know how well it's performing. And there might even be some benefits for this company to perform and share that with either their customers or their management team so that they can show how efficient they are. And then the management team can evaluate where there are room for improvement and what is going well. And that'll help them with making business decisions. Let's go ahead and take a tour of this factory and see what we can find. All right, this is the beginning of our tour. Here we have the plate cutting. They get these stacks of the copper, and the copper comes in different thicknesses, already laminated on the fiberglass material. It's a very popular, famous brand from China, and we'll walk through and take a look at how they're building and manufacturing these PCBs for us. Now, in all fairness, I did already walk through here, and I already kind of got a short little tour so I could give you a demonstration and show you what I'm looking at. There are two tools I thought were really neat. So come and take a look right over here. I won't get in her way, but she has one tool here and another tool. This is a gauge to measure the thickness of the circuit board of the layer copper. And then this tool over here is measuring the circle to make sure that it is a full circle, because it goes through these CNC routers over here and they make the holes with a spinning CNC router to make sure that it's perfect circle. But the reality is she checks it and makes sure every single layer, every board is checked before it goes on to the next station. I counted 19 of these different CNC router machines. Not all of them are busy, but still this factory is very busy. So inside these 19 machines, each one has about 6 heads, and they're moving simultaneously back and forth, making holes and small little holes inside these circuit boards. It looks like they're just setting up the circuit board layers over here, and he's making sure all the little, I think they're end mills. Yeah, I really can't tell from this angle, but I believe there's little CNC miniature end mills for the circuit boards. In fact, you got a whole tool set over here. And that's handy because if one breaks, then you can come and collect another one here pretty quickly. And probably depending on what section you're doing, you have gloves. They're holding gloves, probably for protection, but also for the product itself to make sure that it doesn't get damaged. Now we're going to see a process where they're laminating the different layers of copper together. Really thin layers of copper, but they're being laminated right over here. And once they come out of the lamination machine, let's go take a look at that. Once they come out of the lamination machine, they run all of them through the X-ray to make sure everything is X-rayed correctly. And I also noticed they have a gauge here to measure the thickness. I'm wondering if it's 1 or 2 corners or the whole thing, and then where did they record those? Oh, I see right there. There's a log, a paper log of everything that they're doing for every circuit board that they're assembling. Oh, wow, interesting. So, side note, they got a BMW charger over here. Maybe it goes out the window for someone's vehicle. That's pretty cool. I had the honor earlier of watching this machine move and work. And maybe while we stand here and talk, we'll see it. But the reality is, it laminates it. It goes through a heating process, a pressing process, and all of the different layers are pushed and formed together here. And he is, oh, cool. Let's check this out. This machine has suction cups. It picks up a layer of what I think is steel material. It shakes it, and then it pushes it right over here. And then he manually folds it over, takes the piece, and then from here, he's triggering the machine to move back and forth, but at the same time, he's tearing off the edges of the copper, throwing it into the trash. I saw him standing on the trash earlier, just jumping on it to push the trash down. I'm assuming it's not trash. I'm assuming they're recycling it. And then he takes it, puts it here, and then from here, it's going over into the X-ray area. We kind of skipped this area, but this is the layer prep area where they're preparing the lamination before it goes into the actual lamination side. And it looks like they have clean room material that they're wearing for shoes, hands, face, feet. Layer by layer, your circuit board is getting built right here. And I'm assuming everywhere they are, they're recycling the copper here because that is a valuable resource. All right, we're gonna walk to the other side of this room and we're gonna go take a look at what's happening on the other side. Teaser, they're applying resin to the circuit boards. As you saw earlier, that's planning and that's current production. Now I noticed as I was walking here, I see 1.2, 1.1, 1.5, 1.1, 2.0. So these are different thickness of copper that I've noticed. Down here is 0.7, and I'm pretty sure that's millimeters. This machine is a type of grinding machine that flattens the surface out. So they take it, they feed it through, and it takes it and makes it really smooth for that circuit board. Oh, this is going to be an awesome treat. You can see his hand is on the machine, probably where he placed his hand right up there. They explained this to me. Basically, they take and they put resin on the circuit board. And the point is, when you're doing BGA, which is really high fidelity component, you want to make sure that the circuit board does not short out. So they put the resin in there to make sure that the continuity is continuous and it doesn't have a short in the actual circuit board itself. And it looks like this machine goes up, it has a squeegee, it pushes it, and then it pulls that resin material down on the circuit board itself. And down there you can see the resin is in constant mixture, probably to keep it fresh. So when he needs to apply it with the squeegee there, he can take and put it in the machine, and it keeps that material soft and malleable. I noticed as we walk into this building, the first thing I actually saw is the production planning and what's currently happening. Here was all of the suggestions and cautions for the chemical, for the mechanical, fire, and noise. And as you look around, you have to be very cautious. You have to use all of your senses because this could be a potentially dangerous place if you're not aware or not paying attention. As I was walking through one of those machines a little bit earlier, I felt my eyes start to tear up from the chemical actually in the air. And I thought to myself, is this the lotion I have on my face right now? Is it coming into my eyes? And as we walked away, my eyes actually got better. We're going to walk over there and kind of show you the overall process without getting too far into the machines. Let's go. We're going to exit through that side right there, but we're going to go over here, take a loop, and then go back out that door. It seems like they have some sort of daily production and planning happening there. This room is labeled R&D, chemistry lab, and you'll notice all of the different chemicals that appear in the background with the different beakers. And this individual, he picks up a device and he's measuring the circuit board layer, and they tell me that he is able to measure the actual layer of the material that's placed on the circuit board here. Now, there are a lot of machines. We're not going to go into all of the different machines. This one says plate grinder. And I'm not exactly sure the overall process because there are so many machines and so many steps to bring the circuit boards to life. But overall, there's electroplating, there's chemical dipping, there's grinding, there's cutting, there's drilling. We'll go over here and show you what's happening in this station here. And this is the station that I was standing at, and I could physically smell the chemical in the air. And for my eyes, it was a little scary for my eyes because they started to tear up. I wasn't sure what that was. There's a lot of automation happening here, but they also have a lot of manual labor also happening at the same time. This is the chemical copper sinking line. So they're basically taking step by step, and this machine will dip each copper into each bath, and it will advance it step by step until it gets to the very end. And this is probably 40 feet long machine of different chemical baths. And this is what you're actually going to get at the very end. You're going to get a copper dipped solution on the circuit board. And you can see some of the tooling and fixtures have copper on them as well. Now he's manually touching all these, so I'm assuming that the very last bath is some sort of a water bath because his bare hands are touching that, and that would be very bad if it was some of these chemicals that you're smelling. You also see the fixtures over here have copper on them. This is the electroplating process. And these carts appear to be filled with a water solution, probably for transportation, as you take this, all of the work order travelers from station to station so they know what they're manufacturing. Now this station over here, they're doing the plating, and the plating is the layers in between the circuit boards. You know, they're 2-layer, 4-layer, 5-layer. These guys commonly do 6 to 8 layer. They can do 14 layer, but they tell me that they can do 20 layers, but it's not very common to do 20 layers. Most common is 6 to 8 layers. And what they're plating here is the inside layers for those circuit boards, whether it's a 4-layer, 6-layer, that's what you're seeing. So they're not green circuit boards like you're accustomed to seeing with the Silkscreen on the outside. This is the inside of all those circuit boards. And as you pan down there, you see how long that is. It's probably, on this machine, maybe 60 feet long. And machines do the whole entire process.
step by step. And you'll also notice that they have work orders or travelers with every single order so that they know what's happening. So every single one of these has a work order traveling with it. Wow, this facility is amazing. Here you can see the worker actually putting them in and hanging them up. Something interesting I learned is they don't do a first in, first out customer solution. Meaning if you have a 6-layer board and they happen to be running a 6-layer circuit board line right now, they will add you in. Even if you just came in, if they're running a 6-layer board, they will actually put you into production. So it's not the first in, first out, but rather fill up the line and keep that production going. And your circuit board might take a little bit longer, but that's how they're able to achieve their efficiency, is by taking what they're making, and if your part or your order matches what they're making, then they'll actually bring that together, put it in the order, and get it pushed out. Over here, the worker did his job. He's going to sit, take a break. Meanwhile, the machine is going to advance automatically and go on to the next step.
This is a special room. It's like a clean room. It's not UV lighting, but it's protective lighting to protect this stage of the circuit board process. As you can see from a distance, based on every person's file, their Gerber file, or Gerber, depends on how you want to pronounce it, they're putting a protective layer, which is based on everyone's file. And that protective layer will be put onto the circuit board so that it has protection throughout. So normally you would think that would happen in the electroplating process, but this is a protection process that they are adding and pushing it through. And it appears that you have to have a very clean room for this and a certain type of environment, temperature, humidity, and lighting for this process to work properly. You can see in this room right here, they have the dust machines. They blow the dust off before you're able to enter the room. Looks like they have a tea room or a break room for drinks. And then this is the changing room for folks to put their clothes in before they go into the actual production facility.
This room is the pre-treatment for the graphic transfer process. It is full of machines all around us. We're basically in the middle of this room. It's hot in this room. It's humid in this room, but it doesn't smell too bad. It has a small smell in the air, but I can't quite picture what it is. When you take a look at the machines themselves, they actually look like they're home-built machines, but I'm sure that there's a company that manufactures these machines professionally. But I find it really fascinating, the construction style of the machines. It looks like it's sheets of plastic material that's cut out and then glued together. And inside it has a lot of water, so it's holding it together. It's almost like a fancy fish tank, but it's holding chemicals, and it has multiple different stages for the water and the water cleaning. So here we have the film stripping. It's stripping off the film from the actual copper area itself. And there's different water systems that are going through, filtering the water through here. And you can look up here, all the PVC has different stages that is happening here. When you look really close, these machines are pretty complex. They're full of different cams and gears that are twisting and spinning and pushing water and blowing water onto the circuit board. If you look down here, you'll be able to see the copper exposed and the fiberglass or the FRP below it also exposed. So it's slowly giving it a bath. And this is before they're doing the graphics transfer. This is the pre-polishing line. So here's acid rinsing, pressurize, 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 and then finally they have fresh water. And at the very end down here, they have air blowing. So they're blowing air. I don't know if it's hot air. It feels hot. It definitely feels hot. Onto the circuit boards, and then you see they come out all the way down here, nice and dry. And there's a guy down here who takes these boards and places it onto a cart for transferring.
You'll notice that there's still a lot of manual transfer. You would think it's mostly automated or machines, but it's not. People are actually moving parts around and putting them into machines, removing them from machines, pushing buttons, testing those machines, and putting them on carts. And I realized when I was looking, they're putting them on manual carts where they're pushing and waiting for the next stage. I was thinking that a lot of this would be automated. Over here is the AOI machine. This is the inspection machine, and the individual is placing the components in. There's a camera that tells if it's good or bad. If it's bad, well, I haven't seen any bad ones, so I'm not sure that they have any bad ones. But in another room, there is an engineer that programs this. So this is the AOI, and he manually places it in
a machine, and there's a camera that inspects it and identifies whether it's good or bad. If it's bad, he'll mark it with a pin. If it's good, it'll continue to keep running. And it's important to know that you don't just put a circuit board in the machine or a panel in the machine. There's an engineer somewhere that programs all of these panels, so when it runs in this machine, it's actually testing and it knows what it's looking for. That's often missed. A lot of people don't realize that all of these machines have to be programmed by a human that identifies good or bad, conforming versus non-conforming. So you can see the operator here is identifying components that might not be conforming and making sure that she's fine-tuning and tweaking the machine so that it knows what it's looking for. You will notice that every workstation has a tablet that they're manually writing all of the numbers required for their positions. In order for a circuit board to have the green, blue, red, black color, it has to go through what they're calling an oil painting process. Then after the oil painting process is the silkscreen process. In this room, they have two different types of silkscreens. They have the manual, which this individual is setting up manually over here by hand. And then they have semi-manual, then they have fully automatic. And at the end, I have something I've never seen before I want to share with you. Really cool. Every stencil is made for every circuit board. They have to make a stencil. And these are giant stencils because the circuit boards are panels. They're not individual circuit boards, they're panels where multiple different circuit boards are on one sheet. And they process it by meters here. So square meters, really big. And from here, it'll go into different carrier trays to each worker to then put in process. He's still setting it up. Maybe we'll see him in just a few moments. But this is like the t-shirt silk screening process that you would get to put a label on a t-shirt. They're doing it manually here. Or this machine is called the text laser printing line. And it's basically prepping and preparing the material and the color to be put on and the words to be put on the actual circuit boards. Now, I've noticed a difference between this machine and that machine. This must take a standard size product. Oh, I see what they did. So they're processing so many circuit boards that are this dimension with X and Y. And then when they have different circuit boards in different sizes, they take the tape. It's like a painter's tape. It looks like a green painter's tape. And they basically will filter out the different areas that they want that circuit board to sit on that machine. You'll notice it has a clamp and it holds it as it goes through here back and forth as it slowly processes. And once the process is done, I didn't count. I wasn't really paying attention. I think it went maybe 3 or 4 times and then it kicked out of the machine. And then the clamps, they opened up. All right, so I just learned he's putting it approximately in the same place and the machine must know where that circuit board is, that panel is. It doesn't look like it's very specifically marked. It doesn't look too precise there. Now this machine, I saw him checking the holes. There are probably same clamps here that it goes into the machine, clamps it down, and then it feeds it through. Maybe this one feeds it over, then goes through. All right, so we saw the manual, we saw the semi-manual, and then we have the automatic down here. Now, what I told you was there is something I've never seen before on circuit boards. And she's setting up this machine. I'm not sure if we're going to see it, but we can show you a couple different samples down there where they're able to put different colors on a circuit board. It's UV. They're using a UV printer, which is a full color printer, to add the color on top of the circuit board. Here, she's setting it up, making sure that she's lining it up precisely. And she's been setting this up for a while. Now, I don't know if it can do full color all at once, or if it does it all at different interchanges. I see the different colors on there. I see yellow, black, inks, reds, all through there. But you can see right here, you have your CMYK and you have white as well for the UV printing. UV printing is extremely resilient. Let's go and take a look at a couple different samples of the color that I was discussing. I've never seen this before, so this is completely new to me. So check this out. Some individuals have made some amazing sketches and graphics on their circuit boards. So it looks like they have full color capabilities. It even looks like there's gradient on this one where it can do different shades. I've never seen that before. That's really cool. In this room, they're doing the processing. They are applying a silk screen. I can see the black, green, red, different colors, and I think a yellow over there too. Silk screen treatment being placed on the circuit board. In the air, it smells like an oil, and this is an oil-based paint, so that does make sense. And they mentioned to me that it has some sort of conductivity, or maybe it's non-conductivity material, and that must be the oil paint that gets placed on the circuit board. That's what we're seeing in this room. I'm inspecting to see, and it looks like there's white, black, green, red. So in this room, it's hot. You can feel it's hot, not from the sun, but because there are ovens in this machine. They've already placed the oil-based paint on the circuit board. That's the solder mask. And then the next room is the silkscreen. Let's walk through here. So they must be baking the paint onto the surface. Yeah, and he has gloves on to protect against the heat. Obviously, these are pretty big ovens. You can feel the heat radiating off these circuit boards. And this is the room where they do the silkscreen. We are in the CNC shop where they cut the circuit boards. So if you remember, they come in big square panels, something that might look like this, and then that big panel gets cut out, and then the actual circuit boards themselves will be cut to shape. And every size and shape is different for every circuit board, every project. But it says the CNC molding line, and they're using CNC routers to cut out the different shapes for the different components. After that, it will come over to this line over here, and this is the V cut. And a V cut literally cuts the shape of a V into the circuit boards. Here, let's go down here. Let's go take a look at this. So he's manually feeding those circuit boards one by one into this machine. He's stacked them up, so he has a whole stack, and he can manually take and insert those one by one. Now, I want to remind you, that's not a machine feeding those, that's a human feeding that into the machine itself. And it's cutting the shape of a V, so when you go to cut or break the circuit board, it's already pre-broken or cracked just a little bit for you, makes it a little bit easier for you to manually break those circuit boards. Now, I did notice on the shop floor here, there are QR codes, but when I look around, I don't see any fancy robots moving here. They're all manual carts with wheels that you would push manually. So I find that fascinating. Maybe they're doing some R&D or prototyping of different movement or robot, but this is the CNC area. Once you've built the circuit boards, they have to be tested, and it's not often discussed, the testing. People forget about the program procedures and the testing procedures. This is probably the most critical step in the whole entire process. So here, they have different test jigs made for every single circuit board panel that they make here. They're making jigs and fixtures. Here, he's using this machine, and he's having an issue. It's failing. But I look at a fail as a good thing. That means they found a problem. Now they're going to fix it and figure out how to solve that. When you pan over here and you take a look, you'll see all of the different fixtures here. These are made for every single circuit board that is being made. They're having a fixture made. I couldn't believe this. Let's get a closer look at some of these fixtures. They're highly complex. So you make the circuit board, but then they make these fixtures. When you look closely, you'll notice a series of wiring down here. You'll notice a series of pogo pins. This one probably has 100 different pogo pins in there. They're so thin, you can't really see them. And from a distance, you see all these machines. There's probably 80 machines over there. They're flying probes machines, testing the circuit board, making sure that it has continuity, that there are no issues. This is what they call the high-speed flying needle test. And this is one of the lines. We're at the backside line, actually. And you can see that on a panel, it will go through one by one and test every single test point. Something I find fascinating, I haven't seen in the United States, but they're using this PVC tube to transport air, and then they have a shutoff valve. So that's not so common, but this is a high pressure material that holds that air in place. And then they have that ran all the way down, so they could be setting up a series of new equipment here as well. You wouldn't know it from the video, but this building is huge. We're on the 5th floor, and if you walk up all those floors, you realize how out of shape I am. But we peek in here, and this room is the jig room. And like I had mentioned, every circuit board has a jig made. They have this huge warehouse, and they have to make a jig for every single circuit board panel that they make at the company. It has to go through this process. We have made our way to the final area where they do QC and packaging. So we'll walk through. You see barcode printing over here. So they're printing barcodes to go with every single shipment. And as we process our way through, as we move through the line here, you'll notice that every single set of circuit board, every set is inspected by hands, by humans. This one's really cool. I'm not going to go in close, respect privacy, but the point is they have the QR code with it. There's no silkscreen. There's no mask on this one. So I find that really fascinating. And that circuit board, those miniature circuit boards are 2 millimeters thick. So they're pretty darn thick. but every single set goes through a hand inspection process where they look at it by eyes and they inspect it before it gets packaged. And I do see the QR code stickers that are attending the show, and it'll be going into the packaging. So here's a good picture here. You can see all the QR codes for all the different orders. But I recognize this part because it was just down there. It's the same sort of circuit board, very thick. So it's probably conducting a lot of electricity through there. And they do make extra circuit boards. So when they have an order for 10, they might actually make 12, because if there's an error, then they will have extra for you. You'll notice some of the testing they do an X. And then finally, once they do the packaging, you'll notice that it's in a plastic package just like this with the QR code. And it also has a humidity indicator inside the package. All right, so over here, I'm just learning what she's doing right now. There is a QR code and she's sticking them on, making sure that it matches with what's actually in the package itself. So there's a lot of steps before it actually gets produced and shipped out to you, inspected by hand to make sure everything is perfect. Now, no one's in this room. It's pretty quiet. I see a lot of different packaging happening here. So I know what they do is they actually put the circuit board here. This machine slides this film, it comes down and it vacuum airtight the order. And they put a desiccant packet here just in case there's water inside there. And so it comes out something just like this. Those are bricks. Those are heavy. And as you know, it's going to get shipped to you, and that's the next step. Yeah, so they have their orders ready for shipping, and it looks like stencils over here. They didn't tell me, but I recognize that looks like stencils being made, circuit boards being made, and then they'll be shipped out to the customer. Looks like this package right here is already packaged and ready for shipment. So they're probably waiting for the courier to come and pick that up. It's nice and quiet in this room. They're probably inspecting everything, making sure that all the final I's are dotted and T's are crossed before everything gets shipped out. This looks like a different packaging area, maybe for a different size circuit board down here. Yeah, they have a plastic material comes in and encapsulate it and probably goes through and slides through that machine and then heat seals it up. Really cool. Oh, there you are. Okay. Didn't realize you were behind me. 我们去3D嘛? How cool is that?